Well, good morning, everybody. Here it is, another weekend. Rah, rah, rah. We're ready for the weekend. I am sure ready. And guess what? I got good news. Today, this afternoon, I get my vaccine. So I'm all excited about that. My whole family gets our vaccine this afternoon. It'll be the Johnson & Johnson vaccine, but the good thing is you only have to go once. So we are excited. Anyway, today, rather than show you some flat earther, I wanted to talk about gravity again. I know you guys are getting tired of it, and we'll try to make this one short. But I kind of wanted to explain the reason why flat earthers don't like gravity and are trying to debunk gravity. So let me show you this chart. Maybe you can see it, I hope. So that circle, we can say, represents the Earth, and those green arrows pointing down show that gravity points toward the center of the Earth. So gravity is down. It's a downward force, and it holds you to the Earth. Now I want to show you another thing. Let's rotate a little bit here. Oh my goodness, looky there. It's the same thing. Gravity is still holding people to the Earth. Here we are rotated. Let's rotate a little more. Here we are at 90 degrees. And you can see gravity, the Earth, still same orientation, still same gravity pulling us toward the center of the Earth. Let's turn it upside down. Here's the South Pole is at the top. And looky there, there's still gravity pulling down toward the center of the Earth. It's still the same. It's still gravity. Okay? So when they tell you, oh, those people in the South Pole are going to fall off, that's not true. Not at all true. So gravity's always pulling down toward the center of the Earth. And that's the way everyone on the face of the Earth experiences the pull of the force of gravity. I just saw a recent video by Sleeping Warrior where he again says there's no such thing as gravity, and he has quotes from all these famous people that say gravity is not a force. Well, I beg to differ. It is a force. Brian Greene said it was a force on his TED Talk. You can look that up. He showed how you could start with the Einstein field equations, which, by the way, have the big G inside in the equation. He could take that field equation and do some math, and it becomes the Newton equations. So Einstein does not replace Newton. Einstein enhances Newton. That was from, there's one from Brian Cox where he says that Newtonian gravity is the easier calculation useful for around the Earth, the solar system, and so forth. Einstein is the more correct equation, but it's very complicated and requires all kinds of knowledge of advanced mathematics, and you just really don't need to go there unless you're doing gravity for places far away. Okay, so let me show you here. If the Earth were flat, if the Earth were flat, this is what it would look like. So you have the flat Earth here. There is a center of its gravity, or a center of mass, which is right there in the middle. Can't see. There we go. The North Pole right there. So that's the center of mass. Again, gravity pulls downward, because of the mass that's in the Earth down under here. So you can see how gravity would work when the Earth is flat. This is what flat earthers would think, but they have a small problem in that each bit of matter, every grain of sand, every mountain, every boulder has gravity, pulls down. The problem is, again, that gravity pulls from the sides, also because of the mass of these other objects, the rest of the Earth. Each place where the Earth is pulling down, there's also a pull from the sides by the mass that is out from that point. It'd be better if I show you. This is what really would happen on flat Earth. I don't know if you can see all those, but you have like we did before, you have the arrows pointing down where the gravity is pulling downwards, but then at each arrow or each place on the flat Earth, you also have arrows pointing down from the sides, because at each point on the Earth there is a pull from the side. So gravity would just be a mess. Then there is a real serious problem over here at this edge right here. Again, I'm backwards, so right here at this edge, and at the edge over here, because you don't have any gravity, or you don't have any mass outside that one place, so there is no mass pulling from there. So what you have is you have gravity pulling or pushing inward from here, but you have no gravity on the sides here pushing. You have both of them. You have just one side. So the gravity here is going to be different than gravity everywhere else. So you have a serious problem in that you can't calculate gravity, and things that are at the edge are going to react differently than the things that you see everywhere else. So obviously, gravity won't work on flat Earth, and that's the reason why these flat earthers, Sleeping Warrior, Nathan Oakley, all these guys want to say there is no gravity, because if there was, they would have to explain this problem on the edges. And, it's not right exactly on the edge. It's close to the edge where it begins to change. And so the gravity is going to be different as it approaches the edge. There's just all kinds of problems here. And I hope you'll think about it. Leave me a comment or two. What you think. Maybe you have something to add to what I've said this morning. And we'll talk to you later.